Hi everyone, and welcome to today's lesson. This one is finally time to do some truth table analysis. So before we begin, I'd like to do a quick check that you have learned the truth tables for the truth functional connectives. So the horseshoe, the ampersand, you really need to have those down, memorized very well for any of this to proceed in a reasonable fashion. So let's do a quick practice here. I have some steps here, but I'm going to walk you through it. And I really think you should come back and work on these on your own later on, just to double check that you have the requisite knowledge to move forward. Okay, so what we're essentially going to do is we're going to take some formulas of TL, and we're going to see if we can calculate the truth values of them. So let me just take here this first one. And as you read in the directions, the truth values you're supposed to assign to these letters are true for R and L and false for O and M. So if that's what we're supposed to do, the second line would look something like this. All I've done is replaced R and L with T and O and M with F. Okay, now that we've done this, we need to work our way from the inside out. Clearly the main operator here is the tilde, but we can't calculate the value of the tilde yet because we don't know what exactly it's applying to. I mean, we know it applies to what's inside the brackets, but we don't know the truth value of what's inside the brackets, at least not yet. So let's calculate first the value of the disjunction here to the left of the horseshoe. We know that disjunctions are only false when both disjuncts are false. As such, that one is false. As far as the triple bar statement on the right of the horseshoe, those are only true when the truth values match. Either you have two trues or two falses. In this case, we have a true and a false. That's a mismatch. So that one's a false. Turns out they're both actually false, as you can see. Okay, let's drop some redundant parentheses here. And now this is a lot easier to look at. We still can't calculate the value of the tilde because we need to know the value of the horseshoe first. That is now the smallest operator in this formula in that bottom statement. Okay, so it turns out, perhaps enigmatically, that if you have a false antecedent and a false consequent, it's actually still true. And I know that people don't like that, but that is the way the truth table for the material conditional goes. So just accept it and memorize it. Okay, finally, we can apply this tilde to what's inside the brackets. It turns out this whole compound is actually false. Just like that. Okay. Let's do another one. Here is a much longer statement. The first thing we'll do is replace these sentence constants with their truth values, like that. Okay, now let's calculate the things on the left first. So the whole statement, the whole compound is actually a conjunction. You can see the main operator is that second to last ampersand. So let's calculate the left conjunct first. Now this is actually conjunctions embedded in a disjunction. So let's work our way there. Conjunctions, that is and statements, they're only true when both conjuncts are true. So the conjunction on the left of that disjunction is actually true, but the one on the right is false. They both need to be true for it to be false. So those are both true. Sorry, that's a true and a false. And to the right of the conjunction, we had a true and a false. And so that one's also false. All right, so we just carry that down. We have some redundant parentheses here. Let's get rid of those. Okay, now it's a lot easier to look at. On the left, we have a disjunction. On the right, a negation. Let's handle the disjunction first. Disjunctions, it's only false when they're both false. You have at least one true there on the left. So it turns out this one is true, And of course, if you apply a tilde to a false, it becomes a true. More redundant grouping indicators are there, so we get rid of them. True and a true, that makes true. All right, one more. Very, very long one here. Okay, first we switch over to their truth values, and then we do the smallest operators once again. So let's begin with the triple bar statement here. True and a true, that's true. False and a false, that's true. All right, so let's put those down there. And of course, then after the triple bar statements, there is the conditional F, then T. It actually turns out that's true, and you can see that represented, and it's inside the big parentheses, last true there. And at the end, we just carry down the false. Okay, it's still a little convoluted here, so let's eliminate some more of these. On the left, we see conjunction, true and true. Well, that means that one's true. And by the way, because we have a disjunction there, we once again get to have a true. All right, so that whole left part of the horseshoe ends up being true. Of course, the consequent is false, and it turns out the only time that conditionals are false is when you have a true antecedent and a false consequent, which means this whole thing again is false. Okay, so that's how that works. I really recommend you do some of these on your own, really get the hang of these. But I'll let you go ahead and do that and email me if you have any questions on that. Okay, it's finally time. I posed a question at the top of this section. How do we know these argument forms, the valid argument forms, are always valid? How do we verify that? Well, it's finally time. But first, let's do a quick story time. Yay. At the history of truth tables. So, in 1997, John Shosky discovers a page of a typed transcript of a 1912 lecture by Bertrand Russell with a truth table for the material conditional written by Ludwig Wittgenstein, which means that Wittgenstein was the creator of truth table analysis. But wait, there's more. Subsequent research by Irving Annales showed that an unpublished manuscript identified as composed by Charles Peirce in 1893 includes a truth table matrix that is equivalent to the matrix for material implication discovered by John Shosky, which means that Peirce, and yes, that is how you pronounce his name, is actually the creator of truth table analysis. Okay, let's do this. We're going to begin with sentences, and then we're going to move on to full arguments, truth table analysis, full arguments. Okay, let's begin with sentences. Steps. Number 1, write in the following: the sentence constants in alphabetic order and the TL symbolization of the sentence. So what does that mean? Well, essentially, let's just say you're working with a sentence like A and B, triple bar, tilde B. All you do is write down those constants on the left. Here they are, A and B, in alphabetical order. Now, that's going to make a lot more sense in a second. But the first step is writing out the sentence, and you definitely want to give yourself some space while you're doing these, because you're going to draw in between them. So, okay. Number 2, draw the table. Note, there should be enough columns for the truth value assignments and all the sentence constants and connectives of the formula in TL. There should be enough rows for all the possible truth values of the letter constants. What does that mean? Well, you're going to see in the next slide, but what you need to focus on right now is the amount of rows. There's actually a way to do this, and I'll try to make it as simple as possible. Rule: If there is one letter constant, there should be 3 rows. If there are 2 constants, there should be 5 rows. 3 constants, 9 rows, etc. If you want a mathematical representation of this, it's 2 to the x plus 1, where n equals the number of rows and x equals the number of sentence constants. If you're not into math, that's totally cool. Just remember 2 constants, 5 rows, 3 constants, 9 rows. I will never give you more than 3 constants. That's just rude. So, okay. So looking at our sentence here, what we need is a column for each component there. The tilde gets its own, the triple bar gets its own. Every component gets its own column, except the grouping indicators. Those are just to keep track of which operator you're on. And as you can tell, because there are 2 constants, a and b, it gets 5 rows. The top row gets the actual sentence you're analyzing, and the bottom 4 rows are all the possible truth value combinations. Now that'll make more sense in a second, but this is what a 2 constant truth table looks like. Some people, by the way, like to sort of color coordinate their tables. That's totally cool. Whatever you need to do to keep track of these things. So you can see here on the left in green are basically kind of your placeholders, if you want to call them that. They're your letter constants, your sentence constants, so you can keep track, and if you mess up on the right hand side, you can kind of refer back to this. It's kind of maybe your control group, right? Those are there, you know, to see what it's supposed to look like. By the way, some people make these extra bold, and they do all kinds of things with these. I don't really mind what you do with that. The main idea here is that you have rows and columns. Even the color coordination is optional. I might add one other thing. We'll get to that. Okay, step number 3. Fill in all possible truth value assignments. What does this mean? Well, there's a rule for this. If there are 2 letter constants, just input TTFF for the first column, then TFTF for the second. If there are 3 letter constants, input TTTTFFFF for the first, then TTFF for the second, then TF for the third. You might be intimidated right now or completely confused. All this means is we're dealing with 2 constants in this case. So we're supposed to go TTFF for A and then TF for B. That's all that was said in the preceding rule. This is the way that you're supposed to format it. If you have 3 constants, well, this is already looking like a nightmare, but remember, you need 9 rows, first of all, and you go by 4s, then by 2s, then by singles. So A gets 4 T's, 4 F's, B's goes by doubles, TTFF, TTFF, and C goes by singles, TF. That's all that that step really means, step number 3. So yes, we're not dealing with this yet, so let's put this aside for now. Let's go back to this one. Okay, once you've done that, all you do is, if you want to call it, copy and paste. So the A's, A columns inside the sentence you're analyzing, they get all matching truth values, TTFF, there it is. And the B's, they also match with their B counterpart on the left-hand side, TFTF, just like that. Okay. Number 4, find the main connective. By this point, you really should be able to do this quite easily. It is the triple bar in this case. Okay. Number 5, calculate the values under the connectives with the smallest scope. Note, if there is a tie for which is the smallest scope, compute the leftmost operator first. So, well, it looks like the smallest scope here is the tilde. That only applies to itself and the B. That's only 2 things. The second big or smallest scope is the ampersand. That applies to 3 things, itself and the A and the B. So the tilde wins in the competition as to which is the smallest scope. So let's calculate that one first. Well, tildes are easy. All you have to do is flip the truth value. If it's t, it's f. If it's f, it's t. Simple as that. Okay. Then we move forward and now calculate the ampersand. That's the next smallest. So it's only true when both conjuncts are true. As such, only the top row of the ampersand column is true. The rest are false. Okay. Now that all the small scope operators are taken care of, you calculate the value of the main connective. In other words, the final column, the label, the final column, I've always thought would be a great name for a band. Okay, so we have the triple bar. And when you are calculating this final column, usually there will be a lot of, let's call them distractions on the sides. People sometimes look to the immediate left of the triple bar column and the immediate right to calculate this, but they would be wrong. The triple bar there is applying on the left-hand side, it's applying to the formula in parentheses, and to the right, it's applying to the tilde. So if we want to calculate this, we have to know the truth value of the entire compound in parentheses. So we can't look at the B column, we actually have to look at the ampersand column. Remember, the ampersand column was made, or was calculated, using the data from the A and B column. So that's the one you want to look at. As far as to the right of the horseshoe, you have to look at the tilde, because that one was calculated using the data from the B column to its right. So with that information in place, sometimes I recommend that people kind of cross out these columns that you're not supposed to look at right now. It's totally okay to cross these out. Really, the only thing that matters in the end is the final column. So with these distractions out of the way, let's go ahead and calculate the triple bar column. Remember, it's only true when the truth values match. As such, the only row that has a true value is the second to bottom, where they do match. It's a false and a false, and all the rest are false. And that is how you calculate the truth value of a compound sentence using truth table analysis. By the way, I would be remiss if I didn't say that you should definitely review your work. If you make a mistake early on in one of the operators with a small scope, it sometimes will mess up the entire truth table. One tiny mistake early on will ruin the entire table, so please be very careful with these. Okay, I definitely think you should at this point pause and do these right now. Take some time to perform truth table analysis on these. If you need to, rewatch the preceding section of the video. But this is important that you get down now, because we're going to move on to arguments in 3, 2, 1. Okay, so arguments are a lot like sentences. So here are the steps. Just do everything that we did in the sentence edition, basically. The only difference is that whereas in the sentence edition there was just one sentence, in arguments you'll have multiple sentences. You'll have each of the premises and the conclusion. So let me just show you what a table looks like in a second. Here's the rule for validity. If there is any row on the truth table that contains all true premises, or just one premise, remember arguments can have one premise in some case, but a false conclusion, then the argument is invalid. If the table contains no row showing true premises and a false conclusion, the argument is valid. So again, let me just show you how one of these looks. Here are the sentences, and they're a little shapeless right now, so let me go ahead and give this some shape. What we have on the left, P and Q, those are, like I said, they're kind of the control group. They're just there to remind us of the truth values you're using for P and Q. So after that, we have one sentence, if P then Q, that's premise one. Then a blocked out column, that's kind of like just a space, to separate premises. Then P is a second premise. We're using the / as a conclusion indicator, and Q on the far right is the conclusion. So again, that's premise one, that's premise two, and that's the conclusion. I definitely recommend that you add that extra column that I blacked out there to demarcate your premises and your conclusion. Otherwise, they're going to run into each other and you're going to make a mistake. So please add in that extra column that you're going to just basically cross out, just to make sure you give yourself some space. Don't make silly mistakes. Okay, moving forward. Again, we have two sentence constants, so we need to go in the order TTFF for the first column and then TFTF for the second. So there is the P and the Q. Now we copy and paste the P column wherever we see a P, and the Q column wherever we see a Q. Simple as that. Okay, now we calculate we should identify the main connective. Sorry, that's the next step. Identify the main connective, or in this case, the main column or the final column of each sentence. Let me repeat that, of each sentence in this argument. So for premise one, the horseshoe is the final column. For premise two, it's literally just the P. It's just one sentence constant. So that is the final column. Same thing goes for the conclusion. The Q column is the final column. So I've identified each of the final columns for each sentence. And now we calculate the operators. We begin with the smallest scope and we move towards the final column. Now that's already half done for us, or 2/3 done for us. Let's just calculate here this horseshoe column. Remember, horseshoes are only false when the antecedent is true and the consequent is false. So for this column, the only false is that middle row. So that is what this truth table looks like. Okay, let me do one more thing before I leave this slide. Let me just reiterate that this is really helpful. Crossing out columns that you've already used to calculate another column, that's just a good practice, because you don't need that particular P and Q column, those columns anymore. So I would just, do something to get them out of the way, Okay, let's remind ourselves here of the rule for validity. If there is any row on the truth table that contains all true premises, but a false conclusion, then the argument is invalid. If the table contains no row showing true premises and a false conclusion, the argument is valid. Okay, so let's look here at this table. Notice that this row right here, that is the only row that has all its premises final column being true, right? 2 trues there. In the one beneath it, there's a false, right, in the horseshoe column. And the last 2, there's a false in the P column, right? So that second one, that second row is the only row with all true premises. Now, if you peek over at the conclusion, take a look there, it's true. Which means that whenever the premises are true, it looks like the conclusion is true. That's what this truth table has just demonstrated. Had that been false, it would have been invalid. But again, Q is true in the row that matters. And as such, this argument, my friends, is valid. Fantastic. Okay, what you should do now is practice this ad nauseum. I mean, you should do these at least twice. I swear to you, that's a good idea. So there they are. I left it all P's and Q's. I don't know if that'll help you or not. And what it is here is, by the way, let's take a look at number one. Premise one is if P then Q, then the semicolon is there to separate the premises. So premise one is if P then Q, premise two is tilde P, and then of course the conclusion indicator is always shows you what the conclusion is. So there is a conclusion tilde Q. So go ahead and do those. These are all two premise arguments. I'm making it kind of easy for you. It won't always be this easy, but that's a start. Email me if you have any questions. Ciao.